Alright, similar to what we did before, let's have a look at this one where you are given exact value of the critical points on this original graph. So similarly, I would like to try draw a sign diagram for f dashed of x, which is a derivative function. So to be able to do that, I need to find the critical points for the f dashed of x, which are the stationary points on the original graph. The stationary points, as you can see, there's one here at -2, and then there's another one here at 2. So I have the stationary points, one at -2, one at 2, and then to find the sign of this first derivative, I need to look at how the graph is increasing or decreasing. So first it's decreasing for x is less than or equal to -2, and then in between -2 and 2 it's still decreasing, and then it becomes increasing there. If I try to sort of draw the graph out, I know my f dash of x should touch my x-axis at these 2 points where it's becoming a 0. But first it is a negative number, so below x-axis, and then it touches the x-axis, but it's still having that negative, but it's still a negative number, so it's still below the x-axis, and then it's going back up, and then touches the x-axis again at 2, and then it goes up to above the x-axis. So this will be what the graph looks like for the f dash of x. If I map that back up, I will have first it is a negative number touching the x-axis at -2, and then it's still a negative number. It's still a negative number in between -2 and 2, and it touches x-axis again at 2, and then it's becoming a positive number going back up. So the derivative of a chordate function is a cubic, as what we sketched there. Then, in order to draw the second derivative, similarly, I try to do a sign diagram for the second derivative, and I try to find the critical points for the second derivative. Those will be the points of inflection. So the points of inflection there, that will be one point is here, that is one point of inflection. And then another one is here, that is when the curve changes curvature, so that one is a 0. And as you can see, for the x smaller than -2, the curve is a convex, so meaning that the second derivative is a positive, and then it becomes a concave, so negative, and then it's a convex again, and then which means the second derivative is a positive. If I try map that using a smooth curve, that should be first it's a positive number, and then it's a negative number, and then it's a positive number. So show those features using a smooth curve. That will be a quadratic curve, which is consistent with if your second derivative, well, if your first derivative is a cubic, your second derivative would be a quadratic. So if you put that back into the graph, that will be, well, initially it's a positive, and then it's touching x-axis at -2, then it's becoming a negative, and then touching x-axis at 2, and then it's becoming a positive. So this is what the f double dash to look like, while the other one, the yellow one, is what the f dashed look like.